Good afternoon, everyone. It is with my great pleasure to welcome you to the MGEN Student Showcase. This event is a celebration of innovation, creativity, and hard work, a platform where our talented students share their groundbreaking projects and research with a diverse audience that includes faculty, staff, employers, peers, and friends of our academic community here at Northeastern. Today's presentations highlight the exceptional dedication and ingenuity of our students. Each project represents countless hours of effort, collaboration, and exploration of new ideas that push the boundaries of knowledge and problem solving. This showcase is not just an opportunity for our students to present their work, it's a chance for us as an audience to learn, ask questions, and be inspired by the potential that lies in the hands of the next generation of thinkers and innovators. To our student participants, thank you for sharing your incredible work with us today. We hope you find this experience both fulfilling and empowering as you take your ideas to the next level. Let's celebrate these achievements together. Welcome again to the MGEN Student Showcase, and let's get started. Our first group today will be discussing leak detection and localization in hydraulic fracking. I'd like to welcome to the podium Vishwesh Kota and Ezra Pacifique. Welcome.
So hi everyone, I'm Vishwesh Kota. So today I'm gonna present on leak detection in production pipeline, especially in hydraulic fracking scenario. And our goal is to design a system which detects leaks in hydraulic fracking, and we are using EPANET to simulate this scenario. So first, let's just get a brief on what is hydraulic fracking. Hydraulic fracking is a technique of extracting natural gas from underground water by sending high pressure water into the ground and breaking the rocks inside the ground and getting the minerals from there. So the main challenge in hydraulic fracking is that the substances used are very hazardous, and the challenge goes on when it comes to disposing of the water. So that's a key problem statement which we are addressing. So we want to detect leaks in the disposal system of the hydraulic fracking water, which is hazardous and which can cause a lot of damage to environment as well as households. So our objective is to design a preventary system rather than a reactive system which can detect the leaks earlier and give us a mechanism to avoid it. So the methodology we are using is simulating the same scenario in the EPANET. EPANET is a software, like a water distribution simulation software designed for like residential purpose. So we are using the same software to simulate a scenario where we can simulate the hydraulic frackings. And our final goal is to design a system which can collect data using sensors such as acoustic sensors, maybe flow control sensors, and get all the data from the sensors, run a machine learning algorithm on that, and like predict what's happening in the system and when the leak may be happen and at which location. So the tools we are using is EPANET for now, and we are planning to use FreeRTOS or embedded systems integrated with IoT technologies. So this is this sample. So these are two sample networks we are using. We simulated it in EPANET. The first one you can see there is without any flow control, and the second sample which you can see is with the flow control. Like when it comes to an hydraulic fracking scenario, it's like we can't predict how the flow rate is in the pipeline. It can burst out suddenly or it can be at a subtle level. So we are using 3 parameters to detect the leakage. One is like pressure data, the other is flow data, and the other is demand. So you can see the samples of pressure, where you can see the sudden jumps, like sudden peaks in the pressure, which indicates that there's something wrong in the system. The wrong in the sense there's a leak in the system. So these are values from demand. Demand is nothing but the amount of water drawn from a system. So when there is a sudden demand increased in the system or in the pipeline, which indicates that there is a leak in the system. And then we are using the flow rate. If there's everything is normal, the flow rate should be constant in the system. But if we see a sudden drop in the flow rate at a given point, that means there is a leak happening beyond that point. So this is the overall system trace you can see. So considering these three factors, we want to develop an algorithm, specifically machine learning algorithm, which consumes all this data and gives us and predicts what's happening in the system. So what are the benefits of this project, of this research? As I mentioned earlier, it's the water after fracking process is very hazardous to the environment as well as for the mankind. We want to predict that, stop that leak, and prevent environmental damage, as well as cost effective. We can reduce a lot of water wastage using these systems. Apart from hydraulic fracking scenario, if we can develop the system pretty well, we can use it for the domestic purposes, as well as detecting some gases, just changing the sensors instead of like pressure sensor, acoustic sensors, we can use some gas detection sensors, and we can go there, implement it to detect like methane or something else. And the innovation is to combine the IoT with hydraulic fracking and some machine learning algorithms. So what are the real challenges? Though the current challenges we are facing is simulating and developing an hydraulic scenario where the flow rate and pressure are unpredictable, the demand is unpredictable, which is like completely opposite to the household demands. And the future scope is that if the basics of this project works, then we can integrate it with an AI algorithms which can be further developed to predict multiple leaks and all. So concluding my presentation, like we are working on developing a robust hydraulic monitoring system to detect leaks and prevent environmental damages. So that's it. Thank you for like, any questions? Yep. Thank you so much.
Okay, thank you so much. Next, I would like to welcome to the podium Yu Lai, Yu Li, and J.U. Zheng, who will be presenting on their JobNI, a centralized tracking system for job application management. Come on up.
Hi, everyone. I'm glad to introduce our centralized tracking system for job application management, JobNI. So before diving into our project, I'd like to briefly introduce our team members. So my name is Yu Li, and this is my teammates, Yu Lai and Jie Zheng. We are both grad students from Northeastern University College Engineering MGEN department. And this project is based on under the guidance of Project Jones Yu. And so let's get started. So the reason why we built this project is that as job seekers, today we have so many applications to work on to get a job. Probably 100 or it's a lot. So there's so many applications to work on and with so many information details to pay attention to. So is there any general solution for us to work on this, track this process? So for example, we don't want to miss the application deadline. So is there any way to track the deadline for each application? And also, like, do we have like a cheat sheet for each application so we can record our application question and the answers for each job and position? So our general solution is to build a centralized platform that is built by our job seekers and used by our job seekers.
All right, so this is where Jobney comes into play, and it's designed to be intuitive, serving as a central hub to organize every aspect of job application in one place. And we have 4 key features as listed here. The first one is application management. So our dashboard provides user a clear overview of your application progress, so that it also highlights your urgent tasks and celebrates your achievements. So this will help users to focus on what matters most, that is getting the job without feeling overwhelmed. And also, each application acts as a mini hub so that you could take some notes about the companies, review or update your application progress, and no more juggling between multiple folders or files, because everything will be here in one place. Next is our document center. This feature, as we know, every application comes with a highly customized resumes and cover letters, and we always feel overwhelming to find a place to store them. And this is the place that keep all records of like every versions of your resumes and cover letters, so you could find it here. Then is our LinkedIn connection tracker. It encourages users to reach out to people who work in the companies that you're applying to. So it could be a great resource for you to build your valuable connections and relationships in that company. Last but not the least, our Q&A repository. This feature centralizes all the questions you have encountered during your application, along with your answers for different roles. So this become an incredible source for you for your interview preparation. Since many jobs they have like similar questions, their questions are like repeated. So you can quickly review what you've said before, revise, and also pick out the key points, refine your responses over time. Now, without further ado, let's jump into our demo.
Welcome to Jobney, everyone. Now I'm gonna do a little bit interpretation for during the demo, and let's enjoy the Jobney together. As you can see, this is our dashboard, and on the left-hand side, we have several functions. And in the main part, we have some application that is urgently need to be applied for. So we just list it in the sequence of deadlines. And once you click, you can go to the application page. And on the right-hand side, we have achievements and a calendar where we visualize the data. So we can see how many applications we did and also highlight the date we did applications or add question to the related application. And on application view, we have a list of applications and also like several columns here. And we can also sort them. And this is our search bar, where you can put a keyword and search for specific jobs. And now we're going to double click. We can see a detailed view here. And we're going to create a new application. And this is the newly added one. And double clicking, we can see more detailed information here. We can go to its apply link. And also add resume from our local file. And also cover letter. And we can check our apply status here. And also we can tick the progress we made so far, so we can see how many percentage we've been. And there's a note-taking section where we can put any research we did for this job and save it here. And for the LinkedIn list, we can put any alumni we know or anyone we want to reach out during the application process, and we can add their LinkedIn URL. And also this is our question section where we can put any related interview questions here during our application. And for the company view, we have a list of companies, and also we have a search bar here. We can put the keywords and search for specific companies. And this is our question part where we have a search bar, a search results, and all question lists. And double clicking, we can see the answer below. And setting part, we can upload our profile and change our password. And this is all Jobney about. Hope you guys enjoy the job application journey with me. And that's for the demo part. And that's all for Jobney. Hope you guys enjoy and also have fun with the rest of the showcase. Thank you.
Thank you so much. Are there any questions for this group?
Can you tell us a little bit about the technology that you used to put this together?
For the UI part, we used a scene builder. And for the coding part, we use JavaFX in Eclipse. And that's the stack we use for this project. And we also used some image we got it from Figma. Yeah.
Any other questions for this team? I'm
Yes,
coming.
please.
Is your platform set up to work in conjunction with ATS systems such as Workday or Greenhouse to automate some of those tasks?
Sorry, can you repeat the question, please?
Yep. So is your platform set up to where it can work in partnership with a system such as Workday or Greenhouse to automate some of the functions of Jobney? So where generally for Northeastern, for example, we use Workday.
Yeah.
All of our applications go through Workday. Would you be able to set it up so that it can work in partnership with Workday to automate some of those functions?
So far, we don't have this kind of function, but we have potential to extend this function. So there are a lot of opportunities to add more features to this project, but it's based on the user's needs. So we need to figure out that what the user need to the needs of users, so that we can add more functions or features as you like. Yeah.
We have another question up front.
Some related. What do you know? Single sign-on is when you share multiple accounts. You share multiple accounts over different logins. Like you log in on Gmail, right? And then you go into.
Okay.
You don't have that yet, right?
So far, all the information like username, passwords, are stored in your local computers.
All local.
So it's specific to a local computer. But if possible, we want to implement like some similar features. Yeah.
Oh, that's good.
Any other questions? All right, Kaylee's coming over with a mic for you.
Testing, 1, 2, 3. What's next for Jobney? What is next for Jobney? Where do you see it going in the next year, next 5 years?
So far, we don't have dived into like some kind of question. Probably we want to like, so anyone have like use of Notion, like for efficiency management. So we would like to like Jobney be like a similar software to improve the efficiency for the users. So I'm trying to figure out if there any possibility or potential for that. We're working on this, yeah.
I have a little bit add on regarding on that. So because so far the journey is our final project. So maybe in the future we could extend this application to be like a web app so that users could like use it more like easily. They don't need to like download, install all those things. Yes, they just need to like type in our link and then everything's there for them. And also another thing I think we could do is that we could conduct some user testing, just like what Leo just said. We could learn about what the actual needs from the user and how do they feel about using our platform so that we could refine our system to better serve these customers. So I think that's like maybe some goals for our next step.
One comment, I love it. Just from a co-op point of view, I love this because I think it's a really helpful tool for students. So I just want to encourage you to keep working on it. Keep doing it. Thank you so much.
Really appreciate it. Thanks.
Any other questions for this team? Alrighty, another round of applause for Jobney.
Test. Okay.
Okay, so I'd now like to welcome to the podium an IoT-based system for people with visual impairments, and we do have a live demo for you today as well. I'd like to welcome Abdullah Al-Nassar.
So hi everybody, this is Abdullah Al-Nasir. Okay, today I'm gonna present my project, and I like to walk around. I don't like to stick in one place. Okay, so bear with me. Cameraman, thank you so much. So, yeah, the device I'm gonna present to you today again, it's an IoT-based system that works to help and assist people with visual impairments. Let's proceed. Okay, we're gonna go through some points. I don't wanna read them because it's boring, I know. So let's keep going. So first, I'm gonna start asking you this. Do you know any of your friends, relatives, or any stranger that you know of that is blind or have vision issues? 1, 2, 3, 4, 5, wow, okay. Investors? No? Okay, so, so what motivated me to proceed and go with this research and make this device is one of my family members is actually blind, okay? So I said, like, how does it feel to be blind, okay? And it felt wrong because people are not seeing him as a fully capable human. Like, people would help him out, open the door, transport from point A to point B, and so on and so forth. So I said, okay, well, I'm gonna help him out. Let's go into like one statistic. I don't want to take so long on this, okay? So because we're gonna have a lot of Q&A, I know that. So in the Americans have about 25.5 million, older than the age of 5, who have transportation issues. And a lot of research papers mentioned that it's tough for blind people to transport, even with the apps, Uber, Lyft, or the other apps. The driver could drop the blind into the wrong spot, and how do I find my way? Well, good luck. Ask a sighted person. Okay, so this is a problem. The objectives of my project and my solution is to help the people to navigate from point A to point B. Okay, and basically works indoors and outdoors, and I have a prototype. It's not functional, and we're going to see a demo video. Okay, I have to have the keyboard, monitor, and many things in order to make it run. Okay, but you'll see it in the video. And by helping the blind or the visually impaired to transport from one point to another, I want to ensure their safety. Okay, ensure their dependence. Okay, so I don't want them to rely on any sighted people or guide dogs. Speaking of guide dogs, let's go to the next point, or the previous one. Okay. Fact. According to our research, to train a guide dog, it takes 2 years and $40,000. Okay? We don't want to spend that much. At least not me. Okay? So, and another solution that people use is the white cane, which I have in here. I have my device which is attached to a white cane, but white cane is not effective enough, or it's not good enough to help blind people in certain places, such as places with many obstacles. Okay, what do I mean by obstacles? Sometimes there's a dynamic obstacle, a car or something that you cannot reach at a point. Okay, unless it passes through. Okay, and that's a deal. The methodology and the modules I'm using are mainly the camera module. And just to be clear, okay, my project is mainly meant for people in the remote areas and the rural areas, okay, and people with low funds. Okay, so what I try to do is minimize the project as much as I can, just to have the mandatory components, okay, that helps the blind and visually impaired people. Okay, so I have a camera module that detects the obstacles, and it uses a machine learning library that tells, okay, this is a rock, that's a human, that's a car, that's a train, and tell the blind person, okay, through a Bluetooth headphones, ultrasonic sensor to measure the distance, and the processing unit, which is Raspberry Pi. Also, to communicate with the user, I picked some communicative methods, including the Bluetooth headphones, which is not here, the buzzer, which helps us to notify the user in places where there are high crowds and you can't hear anything, and the vibrator in places where you definitely cannot hear anything. Okay, results. So according to my paper, which is going to be published soon, the average usability score is 9 out of 10. Okay, how did I get that? I compared many papers, and I see the results of the other papers and mine, and I got 9 out of 10. Okay, the other thing is 85% accuracy rate on the object detection system. The camera can identify the object or the obstacle in front of it with an accuracy of 85%, and for our prototype, it's quite good. Enhance the mobility in crowded places and improve the safety, since it detects the objects and the obstacles in front of it, so the person wouldn't need to rely on any other person, would tell him, this is a car, go away from it, you're gonna get hit. These are some of the research papers I compared my research with. The first one is NavCog 3. NavCog helps the user to navigate indoors mainly. BP, it basically uses a relay on top of the transportation terminals like bus station, and sends the data to monitor that's being held by the user and tells them, okay, the bus is coming like soon. Cooking in the dark, it's a mixed reality project where it helps the blind to cook in the dark, or he can't see anything. So Find My Things, it's an AI-driven personalized object detection. It basically takes 4 objects, random objects in front of the blind and saves them. If he lost the project or the item, the app on the mobile device would help him out. RFID bus system, the same as the beep beep, the second one, okay, but it uses RFID. Implementation, the same modules, okay, but what's important to me is to how the flow works. The camera would detect the obstacles, okay, and send them to be processed by the board, and after that, the user will be notified, okay, there's an obstacle, go away from it. Those are the results and what I'm trying to achieve. I don't want to read them again for you because I think I already said all of that to you. And the challenges, okay, since the camera I'm using is like a normal camera, regular one, doesn't have any, thermal reading. So in low lit environments or in dark rooms or in even low lit places, it's not going to be as functional as with good lighting places, okay? And the size, the size is an issue too. I'm gonna tell you in a minute. With a live demo, let me just put that up. So the video on the left side shows an indoor testing. Okay, once I approach the kitchen cabin, the buzzer went up and the vibrator, which you can't hear, started to vibrate. Okay, and I'm closing my eyes just to let you know I'm not opening them. So, because we don't have much time, I'm gonna go to the second video. The second video shows
potted plant, bottle, person, cat, potted plant, cat.
So many objects.
dining table.
Dining table.
Dining table. You are approaching an obstacle.
So many informations I know, and that's because this is considered as a low-lit environment that was taken in Ruggles, and the lighting is in Ruggles are so perfect, so good. Thank you. Okay, conclusion. That'll be it. If you have any questions, please lay them out.
First question, which is the object detection algorithm that you're using? Have you built something from scratch, or is it a pre-trained model?
It's a pre-built model. It's called Mobile Net SSD.
And in one of the demos that you showed, sometimes there are a lot of objects within the range.
Mm-hmm.
So is your algorithm capable of detecting, is there a threshold where, maybe within 50 meters or 20 meters?
Yep. My project is, of course, in the code. It detects the object of 40 centimeters away. I'm sorry, I use centimeters, I know. But yeah.
And does it point out some pressing objects, let's say a vehicle approaching and there's a dog and there are some person walking around? So how will the how will the response be like? What's the most what's the object that the person should pay most attention to?
That depends on the environment, okay? So me at the campus is different from me in Newbury Street, in Africa, in Egypt. Okay, so it depends on the user. I can't say that myself, but the user should be aware of, what's the most important thing. Let's say for places in the desert, there are no roads, okay, but there are camels, which you need to avoid, okay? And again, at nighttime, okay, that's why I have an ultrasonic sensor in the cane. If the place has a low lit environment, the ultrasonic sensor would work, okay, despite there's no light and the accuracy is low of the camera. So it's essential. Even if the camera has flaws, the ultrasonic sensor, the two things over here, will tell the user there's an obstacle. Get away from it. Did I answer your question?
Yeah, and is it like 40 centimeters circular radius, or like how will I know it's coming from left, right, or center?
It's 40 centimeters away from the ultrasonic sensor. It's not around the cane, okay, so it's in front of it.
Okay, thank you.
How many independent devices do you have in the system?
Independent, you mean?
Like camera, ultrasonic,
okay.
and so on.
So I have the buzzer, the vibrator, the ultrasonic sensor, the camera, and the board. Five components in total. Essential ones.
Thank you. Any other questions? Oh, I'm coming. Here you go.
So I also had a question about object detection. So traditional object detection algorithm is used for 2D pictures, but the actual space 3D, which is project into a 2D picture. How did you detect the object, the distance between your camera or your device and the object? Yeah.
So basically, how the object detection works, in short, or
not just the distance, because for YOLO algorithm, you can detect object in the 2D pictures like car or any other object, but it cannot detect the distance between the object and yourself. But how did you implement it? Because for blind people, if there any hazard happens, the distance really important, right? How did you do that?
This where the ultrasonic sensor comes. It measures the distance and it can tell the obstacle or the object in front of the cane is X far away. Okay. Did I answer your question? Any other one?
Thank you. It's great and fantastic. So you're using a Raspberry Pi. Is that the 3V? What model is it? Do you know? The model of the Raspberry Pi, is that like the latest and greatest stuff, or because of performance, right? So you're running like machine learning and stuff like that. So how do you find the performance of the system? Yeah, the performance. How good is it at detecting? I mean, because the Raspberry Pi at the end of the day is a constrained device. So is it accurate? Or not that much accurate, but the performance. I mean, it's like you have low latency. Let's say you're hitting an object. How fast do you get the reaction?
So the responsive time is 0.5 seconds. Have a second. Okay. Yeah.
The other thing is, do you consider putting a infrared proximity detector?
Okay, that's a good one. Mainly, that is a very good one, okay? Mainly, before I work on the project, my idea was to have a bracket, okay? And that bracket, you can buy as much modules, as much components as you want, and you just plug them in, and they work immediately, okay? So the answer for your question is yes. In fact, I'm planning to have like 10, 15 modules more. But since my segment or the people I'm targeting are with financial constraints, they don't have much money, they're gonna buy the project themselves, okay? And hook as much modules as they can buy and need, okay? Any other question?
Any other questions? Oh, yep, I'm coming.
Have you considered also to reduce the size of the technology that you're using and maybe getting substitute the cane with just maybe an earring pair or something that the person can wear and without having the cane?
Okay, that's another good one. So, yes, I did. In fact, if I'm gonna use the cane, okay, let's just fix it up. And I'm trying to hit the ground, the device would go down that means the device is heavy and big, okay? That's why what I'm trying to do is to make another attaching mechanism. I'm gonna use mainly canes. I'm not planning to make it an earpiece ring or something else, because some other research papers made an ultrasonic sensor that can be hooked to your shoe, okay? And that's good and bad, because sometimes you cannot measure the distance between the object at a certain height, okay? So I would say that cane has the best measuring distance, if it makes sense, or it can measure better than the other modules. But yeah, I'm trying to make it way more compact, and I'm trying to make the device price, or I'm trying to make a device that costs about $6 or less.
Fabulous. Any other questions? Okay, another round of applause. Okay, thank you so much. I'd now like to introduce our group, ThinkGrasp, a vision language system for strategic part grasping in clutter. I'd like to welcome to the podium Yao Yao Quain.
Hi everyone, I'm Yao Qian, and today I'm glad to present this paper that be accepted by Coral, and thank my other PhD students, co-author. Without them, I can't make it. And at first, I would like to introduce myself. My name is Yao Yao Qian, and you can call me Freaks. And here's my dog and cat. Without them, I can't finish this paper, so I would like to glad them. And for now, I'm in Lambas for the machine learning engineering corp, and also in 3 fantastic lab. One is more focused on the NLP part, and one is more focused on the robotic area. And I'm glad I have the opportunity work with Rachel, who is in UIUC. And now let's begin the project introduce. First of all, I want to introduce the problem I want to solve. For example, in this environment, if I want to get the tape for just one camera view, actually we can't see the tape, but here are some tips. We can try to, for a human, we can try to move the toy dog to show the tape. And after we grasp the toy dog, the tape will show. But for now, the robotic can't do this thing. In traditional method, they always use reinforcement learning or grasp some random stuff to try to get the tape. And now let's, here is the pipeline for ThinkGrasp. What is ThinkGrasp? ThinkGrasp is a plug-and-play vision language grasping system, and it uses GPT-4o for advanced contextual reasoning. And it can handle the heavy clutter environments, also to generate some grasp pose to get the object even it's visible. And it can guide it to move the object in front of the goal-oriented language. And here, let's dive into the pipeline. First of all, in the simulation, we use low quality of the image. And in the real world, we use the high quality of the image. And at first, we will get an image like it shows, and also we will get a text. The goal is I want to get the tape. And then we pass it to GPT-4o, and the GPT-4o will return the select which object should be selected for now, and also which object part is considered to select for now. And it will give a preferred grasping location. And for this case, it will show us to grasp the brown stuffed dog. After that, we design some arrow handle stuff. Like for now, we want to grasp the brown stuffed dog. We use the LongSam as one of our segmentation method and also the VL part. The LongSam, it can handle the low quality image, and the VL part can handle the high quality image. So we will use the VL part first, and if it's failed, we will use LongSam again. Also, the LongSam can fail again, and that part we will use the original goal. And it can also fail again, and we will just use the object to segment the object in this image. And if it's success, we can get the bounding box. And we also want to let the GPT-4o tell us which grasping location we preferred. We let the GPT-4o to imagine after the segmentation which part we should grasp. In this case, because we use the, actually it's use the K multiple K grid strategy. In this case, we test K at 3 is the best. And after we have this bounding box, we will realize maybe we should consider the stuff around the box. Because actually, if we want to grasp the dog, maybe we need to consider the things around the dog. Okay. And after that, because we use RGBD camera, so we can use the depth image to rebuild the point cloud that be cropped by the bounding box. Because we want the system consider the stuff around the objects we want to grasp, so we will give 10px crop bounding box. And after that, we will use GraspNet to generate poses, like it shows. And we will use the mask we segmented before to filter the poses that, for now, the poses should only focus on the toy dog. And here are some simulation cases setting. We designed two kind of cases. One is clutter cases. This is based on another research paper that used vision language model and also the reinforcement learning method. And we also designed original heavy clutter cases. It's collect 30 objects and the max trying step is 15. As for example, in the heavy clutter cases, we even can't see the object, like it's sometimes being totally hidden. And here are our results. Our results, although our method is super simple, but the results is pretty good. It's super efficient. We could achieve the 98% success rate, and also in the heavy clutter, we can handle this. And here is the real robot result. If you want to grasp a toy dog to show the tape, but the other method can't grasp the tape because it may consider to grasp the cup or grasp the bottle behind the dog, because actually the GPT-4o had the ability to think that which one is the most important object to grasp now to achieve the highest successful rate to grasp the tape. And also in this situation, we want to grasp the fork first and then show the knife. And we also consider we need to grasp the handle of the knife to make it safety. And here is a real robot experiment. For this case, we just use this right camera. And in this view, the tape is invisible. And as we see, arm will grasp the dog first. And then the tape shows, and we can easily to grasp the tape. And this method is totally zero shot, so it's easy to put this in the system we have for the robotic. And thanks for watching and listening.
Thank you so much. Do we have any questions for this project? I'm coming.
I have one question. So what is the input that you are giving to your 4O model? Is it a small video that you're first recording and giving it to your model, or is it a real-time detection?
Actually, we just give a RGB image for the GPT-4o, and because we use depth camera, so we can also have the depth image. And for now, we don't use the video to check the point, but in the future we will.
But then, like, if there are, let's say, instead of one dog, two dogs, and the tape is in between those two dogs, like two dogs in front, and there's a tape that's located in front of it, then which dog will it proceed to, like, remove first?
Oh, actually, for now, we don't consider the situation as we have two same project or same target objects in the environment. Actually, we use the grasp net, so it will generate some score of the grasp pose. If the, although you may want to grasp like the left one or the right one, but for now, our system can handle this. Yeah.
Thank you.
Thank you. Any other questions for this project? All righty. Thank you so much. Another round of applause. All righty, everyone. Again, thank you so much for attending today. We are going to take about a 10-minute break. We have hors d'oeuvres as well as juice and coffee and water in the back. So please help yourselves. I'll give you about a 2-3 minute warning before we go ahead and we start with the other half of our presentations today. Again, thank you so much, and please help yourselves. All righty, everyone. Welcome back to the MGEN Student Showcase. Please take a seat, and we'll get going with our last but definitely not least, 4 student groups here. The next student group that I would like to welcome up is our plant monitoring system. I'd like to welcome to the podium Yudisha Dutta Chaudhry and Shreya Dugala.
Hi, everyone. Thanks for being here today. My name is Udisha Datta Chaudhry, and I'm currently pursuing my master's in cyber-physical systems, and this is Shreya.
Hello, everyone. I'm Shreya from Telecommunication Networks.
So I want to start by asking you all the questions. How many plant lovers do we have here? Yeah. So what if I tell you that the future for monitoring plant health is like not involving any human error, but it's all about precision, seamless integration, and automation? That would be great, right? So we'll be talking about a project which is a matter-driven plant monitoring system. Our objective is ambitious but yet very focused right now. So we're trying to build an indoor plant health monitoring system which will continuously monitor the health of a plant based on these factors like temperature, there's air quality, and light intensity. So we have built this using the Matter protocol. Matter protocol is very new. So it's an home automation protocol that can seamlessly integrate with any Matter-driven devices in a Matter ecosystem, right? So that's the objective. So it basically, traditional plant monitoring systems, there are these problems, right? Where you encounter over watering, or there's less watering, or the plants die due to high light intensity, right? Exposure due to high light intensity. So this indoor plant monitoring system will help you overcome these issues. And we're focusing on this Matter standard. So we'll dive into the system design now. So this is, let me walk you through the system design. So the heart of the system is the Arduino Nano Matter board. And it seamlessly, so the speciality of this board is it's integrating with the silicon technologies, silicon technology, which is enabling us to use the matter-driven protocol. And there are these inputs given to this hub, right? So the nanomatter board acts as the hub. And these are the sensors that we're using. There's a temperature sensor, there's a humidity sensor, there's an air quality sensor, which will measure the quality of the CO2 and the NO2 levels around the plants. And there is a light intensity sensor, which will basically ensure that the plant is not exposed to too much light. So that's the sensing part, right? What's the actuation here? There's a 3-color LED that we have used, which will help the users identify if there's anything wrong with these inputs. And coming to the communication part, right, which is like the key differentiator in this system. So we're using, so all those values given to the Matter board are communicating to this Amazon Echo 4th Gen through Matter over Thread. So Matter is a protocol which seamlessly integrates with any other Matter-enabled device. And it seamlessly integrates in a smart home ecosystem. So this is a very lightweight protocol. It's very new. And this is what we have built using the Matter protocol. And then there's this Alexa app, which helps the users monitor these values from the sensors. So the user will get notified using the Alexa app and accordingly act on it. Yeah, I'll give it to Shreya now.
Yeah, so as we already got to know what are the components that we've used in our project, we have the Arduino nanomatter board, and we have to measure the moisture of the soil. We use the sensors, and we have the light intensity sensor, and also we have the air quality sensors. And we've used, as a part of actuation, we've used the LED lights, the red, blue, and green. And for the software part, we've utilized the Arduino IDE, and we also utilize the pre-built libraries. So one of the main reasons, and other than the plant lovers out there, we also know people who actually kill succulents. So one of the main reasons is that they don't know what exactly the plant requires and what exactly are the conditions it is. So, and even if our homes, we have certain devices which are compatible only to Amazon Echo or only to the Alexa or only to the Siri. So Matter is a universal open source IoT protocol, and it is developed by the Connectivity Standard Alliance. So these which are devices which are from multiple vendors can be brought under one umbrella by this protocol. And the reason why we're able to do this is because all the devices are working on the IP, Internet Protocol. Basically, all of these are connected to the internet, and we use the local network that is out there to be able to communicate all the devices seamlessly. So that's the main feature of this protocol, that is interoperability. And we have, since we are using Alexa app, which is like one of the easiest UI UX experiences that we have out there. So we have simplified experience for the users to operate. And therefore, this encourages for us to be able to encourage this habit of plant. We can be able to encourage this hobby for all of us. And these are the feedbacks that we got from out there, that the users who are found it very easier for them to be able to use. And by this we used, so as we come to this, this is the setup of our project where we use the Alexa app and the board out there with all the sensors. And this is the video.
Plant care using an array of sensors. These sensors provide real-time data on key environmental factors like temperature, air quality, and light levels. The heart of the system is the nanomatter board that we commission using the Matter protocol, seamlessly connecting it with the Alexa. This creates a central hub on the Alexa app where users can easily monitor these readings. For example, the app displays humidity readings followed by temperature data and finally air quality levels, giving users a comprehensive view of their plant's health. To enhance this, the system features a 3-color LED module.
So as we can see, just by using the Alexa app, we are able to see the temperature, the humidity, and the air quality around the plant. So as we can see that the LED indicators that is red is flashed whenever the light intensity is very high, and we have green whenever the moisture content in the soil is less, and we have also we have blue whenever we have the air quality around is pretty bad, that is flashed. So we can see that this is a visual actuation that is out there since it is in a beginner stage, but we also realize that there's a lot of scope in this project where we can integrate AI/ML, where we can have a historical data of all the requirements of the plant and when it can be watered. And we also plan to integrate weather data where you were not required to plant every time, but depending upon the rainy seasons out there, you can even monitor that. And we believe that this can be used in a large scale as well in greenhouse and others. So yeah, our main point is that we could make this as a hobby for all of us. And this is like for transforming the plant care with the help of technology. And it's a sustainable and scalable solution because Matter is a very light protocol and the consumption of energy is also less. Thank you. Any questions?
Any questions? Alrighty.
So for the sustainability of the plant, you use humidity sensor. I have worked on a similar project in my undergrad. So the sensor you are using, are you inserting inside the soil or just getting the humidity around the atmosphere? Because for the plant, you need the humidity that's inside the soil for the better sustainability, right?
Yeah, that's right. So we have to insert it in the soil, these sensors. Just for the demo purpose, this is just to show how it's working. That was the video about, but these sensors have to be installed in the soils. And to measure the air quality, it's to keep the sensors around the plants and see what's the CO2 and the NO2 level in the air around the plants. So that's how it is. So the sensors are installed, they have to be installed in the soils.
Okay, and what are your target customers?
So this is a very lightweight protocol. This can be used right now for indoor plant health monitoring, right? People who have a hobby of gardening, a lot of these plant lovers here would relate to it, that because of high light exposure, sometimes you're not at home or something, you're not able to monitor these plants and they die. And right now the target audience is people who have this love for plants, right? And they want to use this at their homes. So Matter enables this to integrate it with their smart home ecosystem. So this is like a smart system for plant monitoring. But this can even be seamlessly integrated in an agricultural scale as well for a larger commercial business value as well.
Yeah. Okay, thank you.
Any other questions? All righty, can we get another round of applause for this team? Okay, we're moving along here. I'd like to welcome to the podium the IoT Meal Master using augmented reality. And join me in welcoming Mayanik Shada.
Hello, everyone. Thank you for joining today. And special thanks to Professor Rolando Herrero for guiding me throughout the project. So how many of you use YouTube to learn how to cook or just follow some recipe? Most of us, right? And how many of that time we just use wrong set of ingredients, just maybe more, maybe less, almost every time. So how about we try to solve that problem using IoT? And also, have you guys heard about Apple Vision Pro or any relevant headsets? Yeah. How about we try to integrate these two technologies using Apple Vision Pro or some set of headsets and IoT? These things can be optimized a lot. So for a recap, we're using IoT and augmented reality to solve problems on assisting people how to cook. I generally scroll through a bunch of recipes, then I pause the video, I just rewind, and that cycle never ends. So how about so just for a background, we have to prepare a bunch of ingredients. so there are a set of steps that we follow. First, we chop, we wash, or the next step, the most difficult step I would say is measuring the ingredients. And next thing would be just to mix ingredients at various timestamps. So you mix some spices at first or later, and that changes the whole flavor of the food. So here's our brief problem statement. So we just browse through recipes on the internet. We just call our friend or family member to guide us through the recipes. And let's see how many of such problems we are facing. So I conducted a small survey among a small set of group, and most of them said that they faced problem with measuring ingredients, which is what I've been facing on every time. So here's my small architecture that I have developed. So I have a set of sensors, like a load cell, we can call it a weight measurement sensor, that's connected to via a MQTT broker, which is a very lightweight protocol and which is very efficient. So that connects to the VR headset and guides you throughout the cooking process. You have like so there are different elements of the process. So we have like a sensing element. The load cell acts as a sensing element. The cloud, you can send all these values to the cloud, and maybe you can store this information for further processing or whatnot. We have the calibration sensor and telemetry. So the telemetry is done by the MQTT protocol, and it might just not be one application. This set of architecture can support a variety of applications, not just help you with cooking, maybe for other tasks. We've seen a lot of applications of VR for maybe industrial purposes, and also for entertainment purposes, but nothing specific to home or some set of other purposes. So here are all the tools and technologies that I've used so far. I've used a load cell, a smart device that can sense all this information, an AWS broker, which can talk to the device and also to the headset. And we have the headset itself. I use the Meta Oculus headset for my purpose. And also we use some basic OpenAI APIs to convert speech to text, because we don't want to touch the controllers and damage them, because cooking is not a tidy thing to do. Yeah, so this is just a brief overview about how things work. So the sensor communicates with the IoT device via a standard I2C protocol, and then that's transmitted over using an MQTT publisher and subscriber. Here's just a brief introduction about the communication stack that I've used. You can just go through this for more information on how good or bad or what applications this protocol supports. Here's the basic architecture. So the sensor sends the information via to the broker, and then the headset or any mobile device can subscribe to it and follow along. Here's a general finding of my project. So I have like, so what about I select a recipe in a VR headset. So it's my cooktop, and I select a bunch of recipes here. I select which one I have to cook. I select the number of ingredients or I have to select. So you can see the weight of the actual ingredients is 20 grams and should have been like 50 grams in order to have like precise control. You could also select how many people you're cooking for. So let's say you're cooking for people of 2 or 3. So you can automatically increment those and it multiplies it accordingly. Here are some of the results that we've developed. Here's my kitchen top, and I've been selecting a bunch of recipes throughout that, and also displaying the beginner level or the level of difficulty for the recipe. And here's a demo for the video. So it's just a basic dashboard that welcomes you through the application. We called it Rat in the Hat because we wanted to follow the Ratatouille terminology. And you just select, you scroll through a bunch of recipes. We use all hand gestures, so you can just pinch and move around the VR headset without having access to any controllers. You select a recipe, then it shows you a bunch of ingredients. And you select how many people you're cooking for, let's say for 1 or 2, and then the ingredients are automatically calculated accordingly. And then here's on the right, I gather all the ingredients and the IoT device is on just there. It just calculates how things work, the weight of the ingredients, and yep. So once we have that ready, we can move on to the, sorry. I think, so we just go through that, and it guides you through each step at a time. So you don't have to just pause and play the video, and it can just help you throughout the cooking process. The idea behind this is also to support various artists who just create their own recipes, and using that, you can reward them. You can just have like a VR interface wherein each artist on every view of your recipe, they get rewarded, just like how YouTube does. And thank you so much for the time. Any questions, suggestions? Yeah.
Alrighty, I'm coming. I'm curious because I run always in this problem, the conversion between, I'm Italian, so every time I'm looking at recipes in cups and teaspoon, and in my country we use milligrams and grams and kilos.
Right.
So, and I always Google how to convert, but there is always so many different responses. So will your device will be able to convert precisely the quantity in the correct, like if I look at a US recipe, I will have the conversion in grams or vice versa.
Absolutely. So we can even have like a setting wherein you can select which measurement you would like to do, because the sensors are just sending the values, and after that it's all about how we process the data. So it's very much possible.
Any other questions? All righty, another round of applause for this
Thank you.
group. Thank you so much. Okay, thank you so much again. I would now like to welcome to the podium our NeuroDolphin group, a novel mobile system for dementia detection. And join me in welcoming to the podium Rishaba Jain.
So good afternoon, everyone, and my name is Rishabh Jain, and I'm a final year grad student in College of Engineering. And today I'm excited to present my research work that I was doing throughout the past 1 year. And I would really like to thank Professor Yu Jones, who is right here, who helped me throughout the process in my research. And today my research is focused on an app, which is NeuroDolphin, which I created. And it is an innovative, AI-powered, a speech pattern-based mobile app for Alzheimer dementia detection. So here's the outline of the whole presentation and a little bit of introduction. So what is Alzheimer? Anyone? Like, we know like a lot of people in the United States suffer from Alzheimer dementia, and it is like a condition in the brain which makes people harder to think and even to process clearly anything, and you're not even able to like do everyday tasks if you have Alzheimer. And Alzheimer is one of the most common reason, and it's a type of dementia which causes a dementia to a person. If someone is having, and most of the people in the United States are suffering from Alzheimer only. So why does Alzheimer's really happen? So it is due to the proteins in our brain which cause our brain cells to fail. And after some time, it's over the time, it damages the whole brain and make it for a person to even think or function properly. So most of the people with Alzheimer's are over 65 years of age, but it can occur early as well. So if someone is over 30, then I'll suggest you should be very sensitive to your mind health and cognitive health, and you should always check your cognitive health throughout once you cross 40 years of your age, because aging is the biggest risk factor, but genetics and the lifestyle can also factor in the cause of dementia. So over the next slide. These are the few stages of dementia. initially, it's like a failure of memory, which is like a first stage, where you're not able to concentrate, or even you're not able to concentrate on specific tasks, and you are having frequent mood swings and you feel too anxious. Then we have an intermediate state, which is like you're not able to use your mobile device, you're not able to move anything around you, and you have very inappropriate behavior. And the final stage is like complete memory loss, where you're not able to judge things, where you're not even able to drive or do anything. So the main research question is like, can speech patterns really predict Alzheimer's disease early? And can we use speech, like a simple, like I'm speaking, can we use that to find whether I'm suffering from Alzheimer's or not? So the proposed solution, what I build is like to build a model and deploy it into a mobile application, which makes it really readily available to anyone. And the app is completely free, so anyone can use it to monitor their cognitive health. And we use different kind of machine learning and deep learning methods to achieve high accuracy. And the main focus of the whole research is to find the speech patterns, which we can really utilize in our research to detect whether the patient is suffering from Alzheimer's dementia or not. And the whole mobile app is user-friendly, and it's aimed to the general public, and anyone can like simply use it on the go and monitor their cognitive health throughout their lifespan. So why speech? So what I notice in my research is when someone speaks, and if they are suffering from Alzheimer's, they have a slower rate, they speak slowly, they take frequent pauses, and sometimes they forget things while speaking. They don't know what to speak next. And speech is cheaper solution rather than going to a doctor and having an MRI and then diagnose, like visit a medical doctor to check your brain health through a MRI scan. That's why we use speech, which is cheap and you can do it anytime. So our design includes like major data collection, which is very important throughout the process. And our data is not available to public. We had to request it to other organizations like CMU to get the data from them. And we have to do a lot of pre-processing because data is recorded into a medical environment where there are real patients who were suffering from Alzheimer's and there were normal patients who weren't. And we did some cleaning and normalization, and then we trained our major machine learning and deep learning model. We ran into 15 experiments with different speech features and deployed the whole solution into mobile application. So this is implementation of whole project where user comes in and they opens the mobile application, they see a picture, and they're gonna start describing that picture. And the whole process is gonna run through various pre-processing steps, and then we extracting some important features from that speech, and we are feeding those features into our machine learning and deep learning model, and then producing the results out of that. And here are the results, and we see like the traditional machine learning model, after cleaning the data and extracting few features, like very few and specific, we have an accuracy of about 94% from our traditional machine learning models. And the deep learning models are kind of giving us consistent accuracy throughout the process. So we collected we didn't collected the data. We fetched the data from, we requested the data from CMU because this is a private data, and they did whole collection process. They collected doing through a research there, and they have human subjects for the whole collection. So it's not our data and it's not publicly available. Dementia Bank, yeah. It's validated data. And here's a small demo of the whole application, which one of my fiance helped me to record this. So this is our screen where user gonna start.
I see a scenario of kitchen where there are two kids and a mom. The two kids are trying to sneak out cookies from a cookie jar, but the boy is about to fall and the girl is trying to save or take a cookie and laughing at the boy. The jar is labeled with the name of cookie jar as well. Then I can see a lady who is washing utensils but is not considerate of closing the water tap. And I feel all the water is overflowing outside the sink and it's coming into the kitchen. She has cleaned three of the utensils and she has cleaned the plate in her hand. She's just wiping it out, but the water is still overflowing and she is still anxious about it, but I don't know why is she not stopping.
So once we have the recording, everything happens on the mobile app. So your audio is in the mobile application only, and nothing goes out on the servers. So your data is with you only on the mobile application, and all the processing happens on the app itself. We have a deployed machine learning model on the app, and yeah, that's I have a discussion so we found out during the experiments this whole models can or the app can be used for generalized public and in one of the experiments I kind of used presidential debate from President Joe Biden's speech, and the app was able to distinguish things. And in the future we can use enhanced models like transformer models to find out and even combine different models in this whole process. And one of the future works using attention mechanism in speech recognition, which is a trend going on right now, because the prior research is done on natural language processing, which is using text data. But here we are using directly speech data. So that's one of the uniqueness in our research. And thank you so much, everyone. Open for questions.
Thank you so much. Do we have any questions from the group? Keely's going to come over to that side.
So I did some tests on few of the speeches, as I told, and one on my fiance. So the results are positive. So they are I'll say they are able to distinguish perfectly, classify things.
Dog with you, you might get to learn a few things about.
I mean, we still have to do this human subject research, with the actual humans, but I think we need some time for that through the whole process of actually doing the research on human subjects. So that is our next step in the research.
Yeah. Does the data have any way of noting speech patterns over a number of years for any individuals, or is it only ever a one-time test?
So basically the data we had is collected in 2020, and then they did another research, the CMU did another research where they collected the data of the same patient in 2021. So they have the data like a progression data. So you combining both of the data, we can even track the phase of the disease. So whether it's the initial stage or whether the user is on the final stage. So we have this kind of a capability as well in the whole process.
In the demo, we saw one of the activities where there's an image and person is trying to analyze. So speech and cognitive abilities, I feel, are the top two symptoms of dementia that you're trying to analyze. So will there be a mix of activities, or it's just the cognitive and speech that you're going to analyze?
So the research is specific to speech because we are utilizing speech data only. So when I was doing experiments, I found out the speech, what we speak have about 120 features, but not all of them relevant to dementia or even detecting dementia. So I have to conduct various set of experiments and combine certain features only, specific features to whether to find out whether it's dementia or not, to classify, to build a model.
Thank you.
Hi, thank you. I wonder if you could comment, given the kind of joke you made about the presidential debate, What's worse with your system, a false positive or a false negative?
I mean, what we have, like, what I did, like, so from the same speech, like we have from the same person, I used kind of like old speeches, like early stage speeches, like which were in 2020, 2010.
No, I understand what you tried to do, but I'm saying if your system falsely says someone has Alzheimer's or falsely says they don't, which do you think is worse? Because you'll make mistakes.
Yeah.
Which is the mistake you'd rather make?
I totally agree. These are like machine learning models, and we should not be dependent totally on the results. If it make like a false positive, then it's kind of a critical. I would suggest the person to like. I mean, in the app, we still show at the end like this. If you have a disease, like if my application detected whether the person is suffering or not, we suggest to visit a medical doctor to actually have a formal diagnosis there in the app.
Yeah, because usually people would think
Yeah.
false negative is worse.
Worse, yeah.
Because
I think false positive was like.
I don't know.
Yeah.
It's an interesting ethical question because if someone used your tool and said Biden has dementia, so says which is worse?
Yeah.
So far, you're like, what kind of like languages you're supporting? Only English, or you can support?
Yeah, that's so we right now only supporting English language, but we are planning to have a diverse data where we have like speeches from different languages, from different countries, and from the different backgrounds of diversity, and try to accommodate that into our application as well.
So what will be, we have another student working on something similar around Parkinson's disease. What's your recommendation to them? And also around early detection of Parkinson's disease. And they are having some interesting results already. But what would you recommend based on your experience?
I feel like when you are doing like a lot of experiments, it's more about finding the correct one. It's more about like looking at the outcomes and how you can combine different things. Because I won't just say like I picked the best features and did the whole thing. It's more about how you feed the data into the models. It's not like I got the data, the raw audios, and I just feed into the model. I have to did like chunking of that audio, normalize the audios, because the audios get recorded into different environments. So we have to really normalize them, have to like a consistent result throughout the model. And even like when we did the experiments in the application, we have to normalize what we recorded from the mobile app even. So yeah, it's more about how you present the data to the models.
So what will be your response to Dean Gregory about the ethics issue, right? Because I think that should have been that need to be part of your presentation.
Yes.
Right.
Yeah, I think I should be including that as well. I mean, we cannot like trust AI completely. We should have like a formal diagnosis through the medical doctor as well. It's like just a detection with the early stage. So it's not about like I'm telling the stages or anything. I'm telling like be cautious. Like you might have Alzheimer's. It's not like you are having Alzheimer's.
But then it would be more appropriate that a medical technician using a tool like this more than us finding things about freaking ourselves out.
So the thing is, one of the future implementation in the application is like integration of the the health providers with the application. So you can directly share your information, like what the diagnosed result that you got, and even the recorded audio to the medical professional. Like
No, that wasn't my question. The ethical issues maybe require that this app is not available to the public.
Oh, okay.
But more like a medical technician, part of their diagnosis effort, right? Describing that kind of thing, right? It's one of, they have a lot of tools for testing and evaluating conditions, right? And versus someone like me, it's like, oh my God, what happened to me, right? And now I'm creating havoc in the market.
God, yeah. It can be like a tool for the medical professional to have a formal, like a pre-diagnosis kind of stuff, like early diagnosis for rather than a normal public. We can
because ethics and responsible AI is becoming a big issue. So it's really part of the engineering effort. You know, like a bridge engineer will tell you safety is part of their language, right? I mean, the same thing. This is the language we're in right now. So responsible software development requires that we're a little bit more precise and careful about it, just who can use this stuff and why.
Yeah, I totally agree. Like,
thank you.
Thank
Good
you
work.
for the suggestion.
I have one more question, which is the proportion of people that you had on your slide was something like 24% in the 65 to 74 age group. Seems awfully high to me, but that's not really the point. When you go down to, say, the 40-year-olds, and you did mention the possibility of people getting very, very early onset Alzheimer's, when you get down to very low positive percentages, it's going to make your detection using neural nets extremely difficult. And I wonder if you have any experience of that, if you've tried to do that at all.
Good question. So I haven't tried yet with the early. Basically, the data set in what we use include people from like 55 to 75. So they have a variety of age groups as well as like different genders. And for the above, like once you cross 40, is more like the age when you have like chances of early signs of Alzheimer's. It's not like you are having it. It's like it's the age where you have to be cautious because the data say like the people once they cross 40, they have early signs of that because even the patients in this whole scenario are from 45 to 75.
Yeah, that would be another ethical issue if everyone was testing themselves at like age 30 with this and getting false positives. That would be a problem.
Totally agree.
Considering that so far you say this in English, when you normalize the data, are you considering also the fact that maybe a non-native English speaker might pose more, thinking about the words that they need to say next, and is not like a false result of having dementia?
Yeah, so basically a non-English speaker, if someone is not able to speak English, it will be like the accuracy will degrade, obviously, because we are not having that data set from people with different background. For example, if someone is speaking Hindi or some other language. So we have like that in future that to include more diverse data where people are from different cultures and include them into our models. And it will be, once we do that, it will be able to distinguish that as well.
Any other questions? All righty.
Thank you so much, everyone.
Thank you.
And last, but by no means least, I'd like to welcome to the podium Real-Time Stock Tracking Application by Ankwar Varma. Come on up.
Good afternoon. So at the New York Stock Exchange, from Monday to Friday, stocks are traded from morning 9 a.m. to afternoon 4 p.m. So there are 4 important data points for every stock. The price at which the stock opens in the morning at 9 a.m. Then throughout the day, its price changes. So it has the highest price and the lowest price. So that is high and low. And lastly, the price at which the stock closes at 4 p.m. So, and plus there is another data that is volume, that is number of transactions of the stock that take place during the day. So this is open, low, high, close OLHC data. So using this data, we can derive many metrics that can give us insights into which stocks are performing well. So, but there are over 2,800 stocks traded at the New York Stock Exchange. And they the stock prices change every few seconds. So like they're constantly changing and you have so many stocks to track. So it makes sense to parallelize it because every stock is independent of the other. So to parallelize it, we use Arca Actors. So the source of our data is Yahoo Finance API. So this is stock data for Apple. This is a lot of information, but we are only interested in this quote block. So this quote has the data, the high, close, low, and open prices. So this is for Apple, but similarly, similarly for every stock we make such queries and we get this data. I mentioned that we used Arca to like parallelize everything. So this was our tech stack. Arca Actors, Arca HTTP and Arca Streams. So in an actor system, the main actor which spawns the other actors and drives the application, that is called Guardian. So in my case, Guardian simply spawns a stock fetcher and every 30 seconds it sends a stream of stocks. So the next is stock fetcher. So stock fetcher makes the API request and then it extracts the code data. Like I showed you, like there was a lot of information, but we are only interested in the code data. So it extracts that and then it sends that data to stock processor. Now stock processor is the one which calculates all these metrics like relative strength index, Bollinger Bands, etc. And it sends it to DB Writer because we want to persist this because it might be useful. And we also want to aggregate it. So Record Keeper like keeps the most recent metrics that were derived. And Record Keeper also exposes an HTTP REST endpoint so that other systems can like query this data and you can build your own logic to like trade on it. And so Record Keeper every 30 seconds sends the aggregated data to the recommender. And the recommender, using the metrics, it has a set of criteria. So it finds out which stock at the moment is best for buying and for selling. So yeah, so this is the database in which I'm persisting the data. This is the REST endpoint. So you can see on the screen there is data for Microsoft, and these are all the metrics: ADX, RSI, CCI. These are all the metrics for all the stocks. And I'll go to the demo, but you can see here the criteria. It is recommending the symbol BKNG, and here is the criteria that ADX 3.78 is greater than 25. And so yeah, I'll start the demo. So as you can see in the timestamp, this was recorded yesterday at around 11 a.m. And you just notice that it changed right now. So it will like, I've set the frequency to 20 seconds. So like every 20 seconds, the most recent updated recommendations pop up. So yeah. And you can also see the timestamps with which it changes. So now Netflix is at top. Now WFC is at the top, and Netflix, and for selling FCX, so like this continuously changes while the trading is going on. After 5 p.m. when the trading closes, then it remains constant. But while the trading is going on, like it continuously changes. So using Arca Actors, we can like monitor this in real time, and yeah, there is a benefit in like monitoring it in real time. So yeah, so that's it. The use cases are like high frequency traders and trading systems that can use this to their advantage. That's it. I'm ready for questions.
Thank you for this great presentation. So I have like a few questions for you. So as you told that it does give recommendations on stock. So
Yeah.
I wanted to ask, like, does it give like daily recommendations? How does this work? Like, if you are a trader and if you're going for day trading, so it has you have like a variety of options when you are going for day trading. You have like you would wanna go for futures, you would wanna go for options trading as well. Does it give recommendations for futures and options trading as well?
No, but I can work on that, but not at the moment. It doesn't do that.
Okay, and my other question would be, so does it also give like recommendations for like long-term investing if you want to invest in a stock for like a long term, or it's just for like day trading as of now?
Only day trading as of now,
Okay.
not long term.
Okay. Thank you.
My question is, so since you mentioned it's mainly for the high frequency traders, how did you come on the metric that it auto refreshes after every 20 seconds? Like, is it backed by some data or it's just a random number that you've taken?
It was just a random number that I chose for the demo, and it is configurable. So like you can set it on your comfort level, like 20 seconds, 10 seconds.
Okay,
Yeah.
thank you.
Okay, hi. I got a few questions. So first of all, the logic that you're using to calculate is the current price, the low and the high, and how it's moving. Is that correct?
Yes, we use that data to derive metrics. These are standard established indicators like RSI and CCI and volumes. And so that tells us there are certain criteria that if ADX is like above 25, so like this stock is suitable for buying. So whichever stocks meets the maximum number of criteria, that is at the top. So that is how I've.
Right. So this logic would work great for digital assets, don't you think so? Because it's so volatile and you get the current price, the market data right away. So it wouldn't be better to apply it to digital assets? So that's the first question.
Okay. I'm not sure, but actually I'm not aware of what digital assets are. I mean, what do you...
Okay, but for stocks, I think there is a lot of metrics that you cannot just, make decision on in real time.
Yeah.
Because there will be aftermarket, data.
Yeah.
There will be some other metrics about certain stock like Apple. They might have earnings reports and things like that. So have you considered all these other data before making...
No, actually, my focus was mostly only to parallelize everything so that high frequency traders would benefit from it.
Yeah, and the other question is more technical. So I saw your APIs. So sometimes you have like some stocks that have different responses, right? How would you parse it and have it in the same format? Did you run into this issue? Like the Apple data was really clean, right? But what if you have some other stock, like let's say BTC ETF? I'm pretty sure the data would be different.
That was the challenging part. There were like many problems. I mostly get the data from Yahoo Finance API, so it's mostly consistent. But occasionally there are issues, so I had to like account for many edge cases in my parsing, and like finally I got it to work. But that was an error during development. Like it would usually break because the data was not consistent.
Yeah, great. Thank you.
Have you tested? So let's say come up with $10,000 and see over time how much you made.
No, I haven't tested it like that.
Hi, so you are targeting high frequency traders. So what are your recommendation on the 20-second or the 30-second delay? Cause high frequency traders generally just trade in about just less than a second.
Yeah,
so
of
how
course.
do you consider
So,
optimizing it?
I mean, I said that for the demo. I think I could have chosen a lower limit, but yeah, it's configurable. So like it scales because it is based on the actor system. So you can set it as low as you want, and it will scale because it's based on actors. So you can set it at 0.5 seconds. It will still give you the recommendations.
Okay, thank you.
Yeah.
Just a quick question. So you mentioned you're using Yahoo Finance API. So do you think is there any data lag from their end when you're receiving the data, since high frequency trading is generally high value? So how real time is the API data?
I mean, I haven't noticed any lag. It was only like a couple. I mean, the timestamp that the Yahoo Finance API gives us is only a couple of seconds behind the time I see on the computer screen. So I would say like I don't think there's much delay.
But I think couple of seconds is huge in terms of high frequency trading. But yeah, thank you.
Are there any other questions?
Following up on her question about the application around the system. I think that's what she's referring to, digital assets.
Yeah.
So how would you leverage additional knowledge through, say, an LLM?
Oh.
To find any new risk that you didn't know anything about before, right, at the moment of decision? Will this integrate with other AI tools, for example?
I mean, yeah, there is a list of recommendations. So the AI tools can read that, and I have provided the descriptions of the criteria. So I haven't thought about integrating it with AI tools, but if I were to do that, I would feed the recommendations to an AI system, and I'm not sure. Maybe the AI system can then take the decisions.
So this is where the world is right now. That's
Yeah.
what we want to know, how that integration will happen.
Yeah.
It's a very rich piece of knowledge, right? Like she's saying. At least got the backbone going. But
Yeah.
definitely, and also in terms of these AI agents, they're operating the same way, right, that we see them right now. So that would be a wonderful extension. Just here's Robin, okay.
Yeah, there is one project which is kind of following on from this, which is doing exactly that this semester.
Thank you.
Thank you, everyone.
Alrighty, folks, so that concludes today's MGEN Student Showcase. We bring this year's MGEN Student Showcase to a close. I want to take a moment to reflect on what an incredible event this has been today. We witnessed the remarkable results of our students' dedication, innovation, and perseverance. Their hard work and vision are the heart of everything we celebrate in this showcase. None of this would be possible without the collective efforts of so many individuals. First, I'd like to extend a heartfelt thank you to Dr. and Dean Gregory Aboud, our Dean, for his unwavering support of our students and our programs. Thank you as well to Dr. Cal Bugara, our Executive Director, whose leadership and vision continue to drive our programs forward. A special thanks to our program directors, Dr. Maricola Perazzi and Dr. Rolando Herrero, for their commitment to academic excellence and their invaluable guidance to our students. I would also like to recognize the MGEN Co-op team led by Director Laura Mayer and supported by Assistant Directors Jessica Fisher and Marion Mitri. Your dedication to student success and professional development is inspiring and greatly appreciated. Thank you to Kaylee Shitkowski and Farzani Irani, whose contributions to the planning and execution of this event were instrumental in making today such a success. In addition to, I'd like to also say a special thank you to all of our faculty that supported all of our students throughout their research and throughout their coursework and throughout their learning inside and outside of the classroom. So a special round of applause to everyone there. Another quick thank you to our MGEN student front desk staff and our talented content creators for their tireless work behind the scenes. And again, thank you so much for joining us today and supporting our students as they showcase their groundbreaking work. And to our students, congratulations once again on your achievements. We can't wait to see where your talents and ambitions will take you next. Thank you so much.
And I would just like to add a huge thank you to Erin for all of her efforts and the amazing work she did today as well.